Hey, geometry students, it's Mr. Pouts. So we're here with section 4.3. Um, oh yeah, nice, like the picture in my background here. I thought that was pretty funny when I saw it. So I apologize if you're not if you are a Bears fan, I apologize, but that's the Chicago Bears symbol compared to a toilet seat. But anyway, section 4.3. Your goal for section 4.3 is similar to yesterday or last. The goal for section 4.2, only we're coming up with a couple new ways to prove triangles congruent. And those would be right here. So write down this goal. It says I can prove two triangles are congruent using the ASA, which would be angle side angle postulate, and the AAS theorem, which is the angle side theorem. All right, please have those goals written down. And just to recap, we have talked about three different ways to prove two triangles are congruent. Can you name any of them? Well, we've talked about the side postulate, where if you have all three sides of one triangle congruent to all three sides of another triangle, then the triangles are congruent. We also have the side postulate, which says if you have two sides congruent to two sides on another triangle, and then the included angle, meaning the angle between those two sides, congruent on both triangles, then they are congruent triangles. We also have just the basic using that all corresponding parts are congruent. That was the most basic thing that we talked about in the first section. Corresponding parts are congruent. If all corresponding parts are congruent on two different triangles, then those triangles are congruent. All right, we're going to add two different ways here today. The first one, well, we're going to do a couple examples and a couple proofs with them, but the first one is postulate 4.3. So another postulate, not something that we have to prove, but something that we assume is true. It's the angle side angle postulate. The postulate says if two angles and the included side of one triangle are congruent to two angles and the included side of another, then the two triangles are congruent. So as an example or a picture, we have angle A is congruent to angle D, angle C is congruent to angle F, and the included side, which would be AC and DF, are also congruent. Then we can prove that triangles ABC and DEF are congruent. All right, that is the angle side angle postulate. So let's use that postulate here. Two examples. Which two triangles are congruent by angle side angle? You've got some options here. For number one, you're going to have to find the corresponding parts, remember? Let's see. So if I have the corresponding parts, this actually has an angle side and angle for this one. To find another one, this has an angle side angle. This one does not. This one has a side angle angle. So that's not the angle side angle. So it would be triangle SQR, which probably isn't the best way. It's supposed to be probably QRS, but is congruent to triangle. Let's look at the corresponding parts. What is corresponding to S? So it'd be TUV, actually. Nope. I apologize. That is not correct. You'd have to flip this one over to find those corresponding parts. It is actually SQR would be VUT. You kind of have to picture it as it flips around so the corresponding parts are on top of each other. It'd be SQR would be VUT. All right, number two, the corresponding ones using angle side angle. Here we have an angle side and angle for this first one. The second one, oops, we have an angle side and angle. The third one, we have an angle side and angle. All right, we got to figure out which ones are congruent then. Which two triangles are congruent? Well, I think they all are. Pretty sure you could all fit them on top of each other with the congruent angle side and angle. So say they all are. Triangle, but as long as you write it correctly. Triangle IGH congruent to triangle ROQ congruent to triangle PMN. And correct me if I'm wrong, but I think they are all congruent. All right, let's just do one proof with this. Let's see if we can do a proof. The proof says, given the complete the two-column proof, given that BD, segment BD is perpendicular to segment AC, and that segment BD bisects the triangle, or angle ABC. That means it cuts in half. That is our given. All right. Now, let's see if we know anything else from the given. Well, keep in mind, we're trying to prove that, and we're probably going to want to use the angle side angle. We're trying to prove that those are congruent. Those two triangles are congruent. So let's see, step 2. If it bisects ABC, then that means that it cuts these two angles in half, and these are congruent angles. So then angle ABD would be congruent to angle CBD because of the definition of an angle bisector. Oops, angle bisector. So we have an angle congruent. If segment BD is perpendicular to segment AC, that would mean that oops. Oh, then angle ADB and angle CDB are right angles. That's the definition of perpendicular lines. Perpendicular lines make right angles. So then we know that angle ADB is congruent to angle CDB because right angles are congruent to each other. I don't know if we have that theorem, if we have a theorem for that, but if not, we will. But right angles are congruent. So you have those two angles, like this would be congruent to this. And we're looking for the side between them. So we're looking for BD. Aha! Look at our picture. We know that segment BD is congruent to segment BD because of the same side. That's the reflexive property of congruence. Awesome. So we have this side length. So we do have angle, side, angle there. So because we showed that those two angles and that includes side are congruent, then triangle ABD is congruent to triangle CBD. By the angle, side, angle postulate. Awesome. Big smiley face there. All right, now there is a proof that we can do, and I was going to do it for you. Maybe we'll do it another time. I don't want to spend too much time now doing it, but that'll prove this next theorem. This next theorem kind of comes from that last postulate we just used. It's the angle side theorem, so AAS. And it says if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. So for instance, we have A and D are both congruent, angle B and angle E are both congruent, and the not included side, AC, is congruent to DF. Looks like then we have that triangle ABC is congruent to triangle. Let's make sure it's in the right order. If I flip that over, it'd be DEF. Whoops. Right, that'll work. So angle, side. So let me do an example with that, or two here. So, question says, can the angle side angle postulate or the angle side theorem be applied directly to prove the triangles are congruent? Well, let's look. We have angles congruent. We have another set of angles congruent because these are right angles. We have this side that's congruent because that would be the same side, so that by the reflexive property, we know that that side is congruent to itself. So we have angle, side, and angle, side. So yes, the angle, side theorem would work for this one. We already proved that they're congruent now because of the angle, side theorem. All right, number two. Well, we've got two sides labeled there. Looks like we have two angles labeled here. Aha, and we also have the vertical angles. So that'd be another thing that would go into proof. And then we have angle, side, angle, side. Or sorry, angle, side, angle for both. Angle, side, angle postulate would work for both of these. So yes, we can prove that the triangles are congruent in both of these. And the first one we use the angle, side. The second one we use the angle, side, angle. All right. Let's see. Let's see if we have time to go through this one. It says complete the flow proof. Segment BD is the angle bisector of angle ABC and angle ADC. We want to prove that triangle ABD is congruent to triangle CBD. I think we're going to leave this one till class, so we're going to finish it with that. And with that, why don't you have a great rest of your day. Actually, don't forget to go on to your goal sheet and self-assess yourself. Go ahead and do that right away.